Hello everyone, welcome to my channel. Today we'll discuss about the project Euler problem number 3, the largest prime factor. Here the problem statement says that we need to find the largest prime factor of a given number. Before finding out what is the largest prime factor, let us try to understand what is a factor of a given number. Let us consider n is equal to 15. The factors of these numbers are 1, 15, 3 and 5. So 3 into 5 is 15, 1 into 15 is 15. So any number multiplied by 1 is always 15. But if 15 doesn't have these 3 and 5 as factors, then 15 is a prime number. Right now 15 is a prime number, but it does have factors 3 and 5. So if you want to find out what is the largest prime factor, again we need to find the factors for these factors. So 3 doesn't have any factors apart from 1 and 3. 1 into 3 is 3, so it cannot be like split in further. So 3 is a prime number, even 5 is a prime number. So that is why among these two, 5 is the largest prime factor of 15. That's why 5 is the answer for this. Let us try to consider some example where n is equal to some large number. Okay, n is equal to this particular number. For this number, these are the factors. 173 into this number is equal to this big number. Again, 293 into this number is equal to this number, and 14713 into 50689 is equal to this particular number. So here 173 doesn't have any factor, whereas this particular number has factors. So 173 is a prime number. Let's consider to these two factors. So here this doesn't have any factors, but this has these two factors. That's why this is a prime number. And if we come to the third like set, so here we have these two numbers. This doesn't have any factor, but this has these two factors. 173 into 293 is equal to 50,689. That's why this is also a prime number. Among these three prime numbers, 14,713 is the largest prime number, right? That's why this will be our answer. I hope this is clear. So let us try to check one more example. If you consider this number, so 3, 4, 5, 6, so it has so many factors. So 2 into 1728 is equal to 3, 4, 5, 6. 3 into 1152 is 3, 4, 5, 6, and so on. But if you try to see all the numbers, right, every number has a factors. 24 can be 2 into 12, 27 can be 9 into 3, 9 can be 3 into 3, 16 can be like has a factors of 4 into 4 or 2 into 8, and so on. Every number has factors, but these 2 and 3 doesn't have any factors. So that's why these two are the only prime numbers for 3, 4, 5, 6, and the largest prime number is 3. That's why 3 is the answer here. Now let us go to try to find out the logic of how to find out this largest prime factor, and also the code. Here the logic is very straightforward. First we need to find out find out all the factors of a given number, and second step, from these numbers we need to find out whether the number is prime and also whether the number is the large number. Okay, these are the two simple steps we need to follow to design the code. Okay. So here I have grayed out at line number 5 because that is main part is used for optimization. So from line 3 to line 9 you have the step 1, that is finding out all the factors of a given number. Okay, the get factor method at line 3, okay, is defined to get all the factors in a list, and in line 9 it is returning that particular list to the main function, and in the main function we are doing the step 2, that is to find out the prime factor. If you check in line 16 we are checking whether it's a greater or not, and in line 18 we are checking whether it's prime or not. I will come back to this when I explain you using some examples. Okay, so to consider an example, let us consider our first example, which is 15. So let us consider n is equal to 15. Okay, at line 12, n will we will read that particular input 15, and in line 13 we will execute the method get factors. Okay, so in get factors it will return the list of all the factors. Okay, which is 1, 15, 3, and 5. Okay, so that is happening in line 13, and it is saved in factors list. Next, we will consider the largest prime factor, which is at line 14, is equal to 1 initially. Okay, then we will loop through all the factors in line 15 for factors in factors, and we'll check whether it is greater than or equal to the answer, okay, which is 1. So if not, then it will go to the next one, which is 15, right? So second number is 15. So again we'll check, yes, it is true. So we'll again in line 17 we'll try to run the code again, the get factors. We're finding factors of factors. Okay, remember that, not the initial one. So since we have 4 numbers, okay, we get 4 numbers in line 17. F is nothing but the list of factors of factor. Okay, so I think it is confusing here, but still I'll try my best. So second number is a 15, right? So 15's factors are 1, 15, 3, 5 again, and we check in line 18 whether it is equal to 2. Since it is not equal to 2, because length should be equal to 2 for a prime number, because it will have only um, the number itself and number 1, right? That's why it will be a, can say it's prime number. So it's not prime number, so it will go to the next number, which is 3. Now it will check whether 3 is greater than 1. Yes, it is true. Then it will in line 17 it will get the factors for 3, which is 1 and 3, and uh, length of that particular list f is equal to 2 in line 18, which is true. Then it will consider that particular number as a prime factor, which is 3, largest prime factor. So now we have answer is equal to 3. And finally, we will look through the last number, which is 5. Okay, 5 is greater than 3. Yes, it is true. Then it will get the factors of 5, which is 1 and 5. And again, it's a prime number because length of that list is equal to 2. So we will consider that number as a greatest number, greatest prime factor. Okay, so I hope this is clear. Now we will come back to this get factors method. Here in line 5, when you initially design this, you may type it like for number in range 1 to n, or for number in range 1 to n by 2, and you can try to divide that particular number by n. Okay, so and we'll check whether it's the remainder is equal to 0 or not. If it is 0, then only you try to append it to your list. But if you do it for the all the numbers, if n is a very large number, then it's difficult for you. Right? I mean, the code will run again and again and again. As you see here, for 15, it ran 1, 2, 3, 4, 5 times, including the main method at line 13. Okay, so 5 times, I think not 5 times, 4 times, because it's excluded a 1. Okay, yeah, 4 times. So it's the same thing happens like if you have a very big what do you say, if you have like get so many numbers actually, like if you in line 5, if it say for number in range 1 to n or n by 2, then it will have to loop through all the numbers, so you need to do optimization. Okay, if you check in Google, you'll find out. So you can also find out the prime numbers or the factors using a square root. So you can just say use the square root function. So find out the square root of a number. Since it's an integer, since it's a floating value, so we just have to add 1 to include that and also convert into an integer. Okay, why you are adding 1? Because range will not consider that particular number, it will consider -1, right? N minus 1. That's why we are making it +1, and then we'll convert it into an integer. So here, even the large number also actually, yeah, even if you have like 100, it becomes 10, right? The square root of 100 is 10. So it's square root of like 1 million is nothing but 1000. So it is a very good. I mean, you are optimized very nicely here. Okay, so I hope this is clear. So if you have any doubts, feel free to update your in the comment section. So I will try my best to answer your doubts. Okay, that's it for this video.